Here's a video on giving you a problem that is in interval notation. We want to graph that interval on a number line, rewrite it as an inequality, describe it, and then identify if it's bounded or unbounded. So the farthest left number in my interval notation is at -5. And notice it includes -5. So on my number line, here's -5, so say -3, 0, and 2. I'm just choosing some numbers on the number line. Now it's going to include -5 because it has this bracket right here. And it's going to include all the numbers between -5 and 0. And it has to include just a little to the left of 0. So that's an open circle. And that's how you can graph it. If you want it as a bracket to a parentheses. To write this as an inequality, I always put my x in the middle, my variable, and then my number that's farthest left, farthest right, and then greater than or equal to, less than. So how you say that is x is greater than or equal to -5 and less than 0. There it is as an inequality. Now I just verbally described it, so let's write it down. All real numbers for x greater than or equal to -5, but less than and less than 0. The last thing is to define if it's bounded or unbounded. Since this starts at -5 and stops at 0, it doesn't go off in infinity one way or another or both. We say this is a bounded interval. Our last example in this video is just very similar to the one that we just did. We give you an interval from -infinity to +3. So let's go 2, 3, 4 on the number line. It starts at -infinity, and then it stops at 3, and a little before 3 because not including 3. So we have an open circle, and it's going off to -infinity, -infinity to 3. To write that as an inequality, it is x less than 3. To describe it, it's all real numbers for x less than 3. And the last piece, state if this is bounded or unbounded. Since this graph goes on forever in the negative direction, -infinity, it is considered a unbounded interval.